Everyone, welcome to week 2 of the Pre-AP Algebra 2 prep class. The last time we met, we talked about solving equations, just reviewing all the basics and slightly more complicated examples of solving equations. Today, we're going to move to solving inequalities. Inequalities would be your less than, your greater than, your less than or equal to, your greater than or equal to. Sorry, my bunny's making noise. Those would be the inequality signs that we work with. An equation, an equal sign is not an inequality, but actually a not equal to is considered an inequality. We won't really use that today, but just know that that's technically also an inequality. So similar to solving equations, inequalities still require us to isolate the variable on one side. I like the left side. I just always have. Maybe it's because I'm left-handed. Just 1 second, please. Stop that. It's ridiculous. Okay. I don't know what I'm going to do if she won't stop doing that. She wasn't doing it until I started the video. All right. So what we're going to do is move the variables to the left side. You can even wait till the last minute to do that, but I recommend always writing your solutions that way. There's just a couple of extra things you have to remember about inequalities that you don't have to think about with equations. If we multiply or divide by a negative at any point with any of these symbols, we have to flip the inequality sign. It's just a mathematical rule that you have to do. You can graph a solution of an inequality on a number line. And we're going to be doing that with about half of the examples today. We have to choose, though, the number that we get for our inequality value, that it's a kind of a boundary saying everything's bigger than that or smaller than that. We have to either use an open dot or a closed dot. And then we also have to decide what direction are the other solutions going with an arrow, pointing either to the left, where things are getting less than, or to the right, where things are getting larger than. And then our very last two examples will be special cases where we have a compound inequality, which means kind of 2 and 1, and we may have arrows going left and right. Well, yeah, actually left and right is going to happen. So with that being said, let's just practice some kind of simpler inequality problems. And again, I've pulled from Delta Math specific types of problems that I know you will see on the assignment, just to make sure that you feel comfortable with what it's going to ask you to do, what it's going to ask you to type, that sort of stuff. So if we start with this one, this one's just a two-step inequality. And notice they've given you some symbols that you may need to use in the typing feature. They've given you a less than or equal to and a greater than or equal to. They've also given you the word or, which it's kind of up to you. I don't think, no, you won't use that on this one. So we're going to set this up. The inequality sign still represents the midpoint of the equation. We've got something before it and we've got something after it. So the first thing I'm going to do is move this constant of 8 over by adding. It was a minus, so I will add to cancel it out. Now I have a 7x is less than or equal to negative 15 plus 8, which is negative 7. And I'll divide by 7. I divided by a positive, so this sign can remain the same, but it's a negative divided by a positive, so my answer is going to be a negative 1. So you'll be typing in here x. You can hit this button right here, which will put that symbol in, and then negative 1. And then we're going to graph that solution. So we're going to go find negative 1 on the number line, and it is in between 0 and negative 2. And put a dot there. I'm going to fill in that dot because this has the equal to line. This includes the value of negative 1 and everything that is less than negative 1. So that would be on a number line, less than is always to the left. Everything to the left of any point on the number line is smaller than that point. And so I will show that it is going this direction. This is my graphed solution. This is my written solution. All right, here's a slightly harder one. We have a variable on both sides. So again, we will just move the variables to be together. I'm going to move 4z over to 10z with subtraction. That leaves me with 6z minus 2 is greater than or equal to negative 7. I'm going to add 2 to both sides, which gives me 6z is greater than or equal to negative 5, and I'm going to divide by 6. Okay, sometimes it doesn't ask you to graph the inequality, which means you're not going to see a number line in your answer. You're just going to type this in. So I'm going to pull this down, and it's going to give you the option to use any of the inequality signs. We did not change the greater than or equal to because at no point in the problem did we divide by a negative. And then I'm going to type in -5/6. And to get that fraction, you can just hit the backslash, negative, backslash, put a 5 on top, 6 on bottom. And that's it. Okay, so you're going to have lots of problems that are just working through the steps of getting a variable isolated in an inequality. And you may be asked to graph the solution, or you may just be asked to write the solution. Now, other things that you may be asked to do is they may give you an inequality to solve, but what they're asking for is something specific. For example, they may be asking you about integer values of solutions. Remember that an integer is a whole number or the negative opposite whole number. So whole numbers are always positive, but integers can be the positive or negative versions of whole numbers, and also zero. So if you're asked for integer values, you can only consider numbers naturally found on the number line. Just your standard number line with zero in the middle and negative whole values going up and negative whole values going down. Positive whole values going to the right of zero and negative whole values going to the left of zero. And so the first question here says, determine the smallest integer value of this solution. So when we get the solution, we can't answer that question yet until we isolate x. We're going to evaluate what it's asking or what it's telling us the solutions are and determine what is the smallest whole number or negative version of a whole number that is included in this solution. Notice this does not have an equal to underneath. We'll talk about that in a second. So I'm going to add 7. That's going to give me 4x is greater than -10, and I'll divide by 4. And when we divide by 4, we end up with a fraction, or at least not a whole number, -5/2, which is the same thing as -2.5. So that's not even an integer, okay? So we are looking for what is the smallest integer value of x of this solution. X is greater than -2.5. So if you think about the number line, let's just say that we were graphing this, and this is a negative. So I'm going to start with 0. -2.5 would be right here. It's not an actual solution. It's just the boundary of where all the greater than this value solutions are found. So I'm going to show that all my solutions are to the right of that -2.5 value. What is the smallest integer that I see first in that solution? And that would be any of these numbers on the number line that are whole. -2 is the smallest integer that is included in the solution. -3 is not included because it's not greater than -2.5. The smallest solution that is included in this, that's an integer, is -2. And so you're going to type in -2, literally just the number -2. They could also ask you what's the largest, and you would be looking for, it's probably going to be a less than problem, and you're going to be looking for what is the integer closest to the dot that you made, but still less than. So it's just the reverse. Now you also could be asked to adjust a specific interval. So it says you're going to solve this for x, and you're going to state all the integer values, all the solutions that are included in between 2 and 8. And notice this includes 2 and 8. And you're just going to list those numbers with commas in between them. There's not going to be a lot of them. So I'm going to solve for x just like we have been. The number itself that we get in our solution may not be an integer. Oh, sorry, that's a 9. I'm going to divide, and I get x is greater than 3. So let's think about that. Let's say this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3. Greater than 3 would be this direction, not including 3, right? So what integers between 2 and 8 are included in this inequality? Well, not 2, because it's not actually part of the solution. 3 is also not part of the solution, but 4 is part of the solution. 5, 6, 7, and this upper part of the interval that they gave us, 8. So I'm going to type in delta math 4, comma 5, comma 6, comma 7, comma 8. Those are the integers that are included in this inequality solution between just the range of 2 to 8. Okay, that's what an interval is. It's just a range. It's giving you a boundary, an upper and lower boundary. All right, every time you type in a comma in Delta Math, it's going to open a new little answer box. So you'll just end up with 5 little answer boxes here. All right, now, can we test solutions to inequalities? You can. In fact, you can plug them straight into the inequality as it is, or you could go ahead and isolate this and get the x by itself and test which one of these, if any, or maybe all, or maybe just some, are solutions to this inequality. I actually like to go ahead and solve it. This just gives us more solving practice. So if I move this 9, that's a constant, away from that side, and I do it with subtraction, I end up with this. Now, this is the first time in our notes where we've had to divide by a negative. Don't forget. That means the inequality sign must flip. It's going to change, and that's because we divided by a negative. And so when we divide negative 13 by negative 5, the negatives are going to cancel out, and we end up with 13 over 5, or 2.6. Positive 2.6. So anything less than or equal to 2.6 is a solution. Is 0 less than 2.6? Yes, it should work. Is negative 2 less than 2.6? Yes, it is. Is 5 less than or equal to 2.6? No. So we want to choose the answer choice that only includes answer 1 and answer 2. Those are the only two included. And you can always test a 5. You can test a 5 up into the original problem, and you will get something that is not a true statement. But if you test the 0 and the negative 2, they will both give you true inequalities. Now, they could give you a bunch of numbers, and they're going to ask you to select the values that make this inequality 2. They also want you to solve for G, and that's what I would do first, and then go back and choose which of these is part of the solution. So I'm going to take this inequality that they gave me, and it's almost solved for G. I just need to get rid of the negative in front of it. I do that by dividing by a negative, which is going to flip this inequality sign, and a negative divided by a negative is a positive. So I am looking for all values of G that are less than 8, not equal to 8, not greater than 8, but anything that is less than 8. And down here, I would click this little arrow, choose the less than button, and type in 8 right here. So we're not going to choose 8, and we're not going to choose any number bigger than 8. 7 is bigger than 8. 8.1 is bigger than 8. 9 is bigger than 8. But this is less than 8. 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 This is barely less than 8, but it is. This is definitely, anything negative is less than a positive. And even this positive number is smaller than 8. So I'm going to select all of those, and I'm going to make sure I have my inequality written here, and I'm done. Okay, you also could have linear inequalities with fractions and decimals, and we would handle those exactly like our equation counterparts. It's just that we have to remember in the end that there's an inequality for our answer, and that if we at any point divide by a negative, we're going to need to flip the inequality sign. So I'm still going to treat it like an equation for the better part of this problem. I'm going to go ahead and multiply, distribute, let me say that. This is a negative 1/4 times a negative 6x. That's going to be a positive, and I'm just going to go ahead and keep this a 6/4 x. 1 times 6, or negative 1 times negative 6 is 6, 4 on the bottom. Negative 1/4 times 5 would be negative 1 times 5 divided by 4. And at this point, I would do what we did with equations, which is I have a denominator of 4 that I don't want to see. So I'm going to multiply everything in the problem by 4, because that's going to cancel out those denominators. It'll make this number a little different. It'll make the coefficient of x on this side a little different. But at least we'll have our fractions gone. So those 4's cancel out. This becomes a 6x. These 4's cancel out. This becomes a minus 5. And now I'm just going to combine my x's on one side. That'll be negative 2x. And I'm going to combine these two numbers, which would be negative 29. And I'll divide by a negative. I divide by a negative with an inequality, so that means I have to flip the sign. You can leave it like this, or you could also write 14.5. Either way, they'll accept either answer. I would say if you started with fractions, leave your answer a fraction. If you start with decimals, you can definitely have an answer as a decimal. So we'll practice with a decimal. No different, just it's a decimal instead of a fraction. So I'm still going to combine my x's, or first I'm going to distribute. This is a less than. Negative distributed to a 2x would be this. A negative distributed to a negative 1 would be a positive. I'll go ahead and combine the like terms on this side, 4x minus 2x. I like my x's on the left, so I'm going to bring that 2x over here, and I'm going to move the 3.9 over here. Oh, Lord, there she goes again. Negative 2x, and 1 plus 3.9 is 4.9. And then I'm going to divide by negative 2. And I end up getting a change in the inequality symbol. And this ends up being negative 2.45. And that's my answer, and that's what you would type in. Okay, we just have 2 more problems. These are our compound inequalities. You're going to see a lot more of these in Algebra 2 than maybe you saw in Algebra 1. I'm assuming you saw at least some in Algebra 1. Compound inequalities happen when you see 2 inequalities part of the same problem. Usually that always really means you have 2 points that you're going to have to put a dot, open or closed. Remember, I'm going to show you this picture. This is the baby. Oh my goodness. This is the baby, and this is the robot. And these symbols have meaning, and you're gonna know all of these symbols if you don't already know them by the time you're about in the first 6 weeks, I would say, or first 9 weeks of Algebra 2. So if you have a less than or a greater than, that is always going to be graphed as an open dot on the number line. If you have the equal to lines underneath, it is always going to be a closed dot. Okay, so I'm just going to kind of leave those up there just to remind you. So you're going to have 2 dots in your inequalities, and then you're going to have arrows either going towards each other. If you have points here and here, either those arrows are going to go towards each other and meet, or they're going to go opposite from each other. You're going to have 2 arrows, you're going to have 2 dots. So what we're going to do is, and I want to show you that typically when you see the word and, you're going to have the arrows going between each other. If you have the word or, you're typically going to have the solutions that here's the dots and the arrows are going away from each other. So I see an and right here. That to me means I'm expecting to have 2 dots with arrows or the shading going in between each other. So I'm going to solve each of these independently, plot my solution on here, and we should see that. And again, if you ever have no solution, if you ever get something that's not a true statement at all, you're just going to leave the number line blank, and you'll put this symbol right here that's like a 0 with a slash through it. You can put it right here. Okay? My rabbit can't get to her hay. Do you need your hay? Do you need your hay? Are you having a hard time? My goodness. Just eat it. Eat the hay. You have hay. You can get to it. You don't need to scratch. Okay. So I'm going to come solve this over here. 2x minus 6 is greater than or equal to 2. That's a pretty easy solution. You end up getting greater than or equal to 4. And then we also have the second one that they wrote. This is an and. 2x is greater than. Oh, these are both greater thans. Okay, so this is a special case where you're going to get 2 solutions, both going the same direction. We're going to, we have to pick the inequality that is the most, hold on a second.